Next up, we're just going to start with a pretty straightforward operation. I'm going to drill a hole 1/64 under 1/2 inch, ream 1/2 inch all the way through this whole part, which is kind of deep. Ultimately, that is what's going to hold this guy in place. You'll notice the D shape of this guy. It's 0.875 there, 0.75 there roughly. This was probably for a wrench hold. What I'm going to do is I'm going to put a threaded rod with some Loctite in this. It's going to go down. There's going to be a threaded wheel in here that I can rotate that will raise and lower this. That's the tilt mechanism. Now, in order to do this D shape, originally I was just going to do round, but that's not going to leave a lot of meat on here. It was probably a design flaw of mine. So what I've decided to do instead is I'm going to drill and ream this for 1/2 inch, and I'm going to use that to center on a rotary table this hole. And then what I will do is I will get this part perpendicular to an axis with the rotary table set at 0, and with a 3/8 inch end mill, I use tangent radius and use this curve here and this straight line to find the tangent radius and so I could figure out what the angle of rotation was. And also just moving this to the peak here, there's a 3/8 inch end mill. This has to go about 1.6 inches deep. So if I go 0.2496 up and then rotate plus or minus 48.5 degrees, I will get this curve. And then I can do the exact same on this other side. And then if I go straight out and over up 0.1651, I will clear out almost all of the material inside this part. Then I follow up with a 1/4 inch end mill and just go up and down on both sides by 0.1872 off a center line. And that will allow me to get almost perfectly this straight section here. And you will notice that this is slightly curved. I can just round this off a bit, and that will create my D profile, which will help support this part. Run out of range on the quill. Just before I broke through, literally. That's pretty amazing. So the only reason I'm going to all the trouble of reaming this is because I want to use the hole out the bottom to locate this part very accurately to cut out the top portion. 1/2 inch reamer should have made perfect sense that it's not 1/2 inch on the shank. For clearance sake, let's go down one size. Yep, there she blows. That'd be it. 7/16. Probably not an accident. Wow, that was a lot easier than I thought it was going to be. That went very smoothly. Okay, now that I've done that, if I wanted to take the easy way out, I could just bore this hole for 0.875. And that would make it a lot easier on me, but I think we're going to try the rotary table version and make a D, because I want to put set screws in here, not only to lock the motion, but also to keep it stabilized. And if it's flat, then because if I just did a round boring hole, this thing would be supported like this, but it wouldn't be supported very well like this, and it could rock a little bit, even though it's going to be in here fairly deeply. I planned on it being almost all the way down when it's perfectly level, so it should be mostly supported its entire length. So maybe this is an exercise in futility. But I want to make sure it's supported this way as well. So I was going to put set screws that push on this, like 3 of them. I'm still going to have at least 1 set screw to lock it off, but I think if I have the D shape, it'll fit better and provide more support. So we're going that route. All right, so I've got my rotary table mounted to the milling table, and first I got the rotary table, I set it down and I indicated in dead center on the rotary table using the bore, the Morse taper 3 bore through the center. Then I've got these Morse taper to 3/8 24 threaded adapters, and I made one for 1/2 inch that fits into the bottom of this guy here. And it's made out of brass. It's just for alignment. Then I set this guy on here with that dead center because it's connected to the brass bit. It's, the brass bit that I reamed earlier. So that aligned this whole dead center with the quill dead center. Then I indicated I set this at a known angle, and then I indicated this guy in along its entire length. And it required some clamping magic, definitely a little bit out of my comfort zone clamping wise, but now we should be able to do the D. I've also locked the table. I set it exactly on one setting, and I've locked the table, and we're gonna go from there. There's my sandy check with X and Y on 0. The end mill is centered in the hole. You'll notice the really long end mill. That's because I have to go in a total of 1.6 inches. I can go side to side 0.1872 and then rotate about that axis and do the minor diameter, the inside diameter that'll fit inside these two flats. So I put a new 0 on the scale over here, so that 0 is 0 since it was convenient. I did remember that this other thing was on 40 degrees, the built-in marker, but now I don't need to worry about it. So what I'm thinking about doing is loosening this guy up. Then traversing my X, I can go 0.187. We'll stop there, and then I can rotate. Now the question is, did I leave enough clearance to get over my vise? That is a very good question. I'm about to find out. It's really close. Am I gonna have to take my vise off? Oh, the jaws are gonna hit. Oh no, really? It misses by a tiny fraction of an inch. I'm gonna have to move my vise. I was hoping not to tram it in, or I could take the jaws off. That might be easier. So this is one way to do it. Another way is to plunge cut it, which we will try next. Because this is going very, very slowly. We're only a 1/4 inch depth. Let's take this guy up, let's clear some chips. All right, let's go over 0.180. And now, and then if I want, I can rotate this and just keep taking bites. And you'll notice how much faster this is. I'm doing full depth. One of my problems is I'm not clearing chips very well. think I'm going to remove my vice jaws on the Kurt vise here to make it easier to swing this part around. Turns out the movable jaw can go far enough back to just barely clear, so I only had to take the front jaw off to make it work. So we can nip this last bit and then see if we can do a full rotation, see how that works. It's a lot of engagement. Probably with a little more lube, I'd have a better, cleaner. Ooh, that's a big bite. Always try some lube. Of course, when I use lube, the chips aren't clearing as well. All right, that worked out really well. So now I'm going to do the part where I need a very precise angle. So I can take this guy, pop him up. I need to return to 0 in my x-axis, lock off my x-axis, and now my y-axis needs to change by 0.2496 ultimately. So that's where the larger diameter curve is, 0.2496. Let's see, we're just going to go 240. And then I've calculated I can go 47.5 degrees either side. So the maximum extreme in this distance is 45, 46, 47, and a half is right there. And then I'm going to go back and do an interim 22 or so, just to remove a good chunk of material. And then we're going to go the other direction to 47.5 degrees. But as long as we're going, we might as well do the 25. Keep going until I hit right about here. Now here's the part that I'm not sure I can pull off. Can I rotate all the way back to my final angle, which would get me Okay, now the trick. Let's go to the final dimension, because that actually looked like it was working pretty well. So we need to go 0.2496. We'll go 0.250. was perfect. Now we need to take our y-axis, loosen it up, and go the other direction. Last but not least, come back to 0 on our Y, go over the total amount on my X, which is 0.187. Okay, I'm going to lock that. That's my X direction. I want to plunge all the way down to 1.6. And then I'm traversing on my Y 0.165. And other 165. Back to 0. And then we're going to take our X, go to the exact opposite side. And we're going to go 0.187. Plunge down. To 1.6. Then do my plus or minus 0.165. And that should be a very rough better than a rough approximation of an accurate fit. We can actually test the part. I may need to use a 1/4" end mill to get farther into the corners, but let's see. So you can see it's a really close fit, but where these corners meet the curve, I'm off. So I got to take a 1/4" end mill and clean that up. Now that's going to be even harder because 1/4" end mill is even more sensitive to deflection than this 3/8 end mill is. I just need to fix my corners, which is where I'm headed. So with a 1/4" end mill, you can see, I don't know if you can see right there, see that little gap of material that's left? That will be much, much closer with the 1/4" end mill. So all I need to do is go into the corners with the 1/4" end mill and we should be good. So, and I've got, you have to compensate for the diameter of the end mill. That's why I use these circles to draw this. So the first time I went over 0.1872 with the 3/8" end mill. This time I'm going over 0.2497 for the 1/4" end mill. And we're just going to take off a tiny bit of material. Whoops, I was kind of afraid of that. Apparently it caught on a burr down there. Broke my end mill off. Well, there goes 50 bucks. That was not a pleasant experience. I was being really slow and careful too. I'm not quite sure how it did that, but surely did. So we'll have to come up with plan B. Since I broke the 1/4" end mill, I slightly modified the part by just sanding, grinding off of the sharp points on the flats here. I don't need them anyways. All right, so there's the fit. It's a good one. There's a little bit of slop mostly because this casting was not a precision machine job, it was cast. So I had to file and sand and compensate for that fact. Maybe if I had to do over again, I'd try and make this part myself from scratch. That might be an interesting experiment all by itself. We'll just see how this works. There will be a set screw going this way, pushing on this, that will lock this up against the side here. And I may add a set screw from this side as well. I'm not entirely sure yet, probably one on the front. We'll see about that. Just to take out the tiniest bit of slop, because I really don't want the top wheel wobbling at all. We want it to be a nice, super smooth fit. One last thing, there's the inside of the D-cut hole. It came out very much smoother than I thought it was going to be, considering there's so much stick out. And there's where the 1/4-inch end mill broke. Put a nice ding in the side. Very exciting, I'm happy about that. And here is how I oriented the part. There's my 1/2-inch threaded brass piece that fits on top of the 3/8-inch 24 MT3 center. These are just some ground spacer blocks I made, and that's the whole setup.